Hello and thank you for your attention. My name is Liam Innis. I work at the Renewables Grid Initiative as Manager for Energy Ecosystems. Now, having already explored in previous presentations the causes of bird mortality through electrocution and collision around power lines, in this presentation we'd like to explore some of the barriers to implementing these solutions and ways to overcome these barriers. Specifically, we'd like to build on and share our experience in working in Europe and also from the experience of our partners. So first, let's start with the issue of collision with power lines, whereby birds fly into the wires, normally the upper, thinner earth wire, and die through a broken neck or from injury thereafter. The solutions here are applying bird flight diverters directly onto the line so that they become more visible for the birds, or indeed placing the wires underground so that all risk of collision is removed. However, when it comes to implementing these solutions, often there's unclarity on which markers should be used. Indeed, there are many different types of markers on the market, and research has shown that many factors influence the effectiveness of these markers. These factors include geographical factors, climatic factors, so the weather, which species are present, and the behavior of these species at different times. Furthermore, it can be difficult to know where to prioritize to apply these markers for maximum effectiveness. The grid is vast and birds travel a lot, so in order to be sure that you're getting the most out of your money and applying these markers in the best, most effective way, there needs to be clarity on which parts of the grid to apply these to. Furthermore, and importantly, are the costs and the perceived costs of applying these markers. So the next big issue is mortality through electrocution, whereby the birds touch charged components or a charged component and an earth component and cause an arc and die therefrom. The solutions here are insulating the different dangerous components with plastic or with silicone. Pylon design is a key factor, so moving components or changing the pylon design completely so that they don't pose a danger to species, for example expanding the distances. Installing perching devices so that the birds don't have to interact directly so much with the charged devices, and also putting the cables, of course, underground to remove all risk. However, again, there are barriers here. For example, which materials should be given favor here? Where on the grid should be prioritized? And the costs of implementation is always a key point. Now finally, the issue of disturbance of nesting birds on or close to the power lines. The solutions here are to consider altering the maintenance routine away from the breeding periods of the birds, or indeed using alternative technologies. This means maybe rather than a large noisy helicopter, drones could be used. However, when it comes to the barriers here, there certainly are some. For example, which techniques exactly to favor, which species and times to prioritize, and the costs and changing the maintenance routine and training the staff to be able to do this. Indeed, there's not necessarily a great deal of ornithological expertise within grid operators, and this knowledge must come from somewhere. Now, when we consider together these issues and the solution strategies that exist, it's perhaps startling or perhaps not surprising at all that the barriers to their implementation are indeed very similar. And it comes down in many cases to data, or indeed a lack of data, a lack of awareness, or cost, or indeed a perceived unbalance between cost and benefit in implementing these measures. Now first on data or knowledge. The understanding is there that birds are dying with the grid, but in many cases there is very little monitoring or indeed no systematic monitoring of this issue, which means that grid operators often don't know which species are dying with which parts of the grid and where it's most acute, where it's the most dangerous. Also, there is understandably not a great deal of ornithological expertise within grid operators themselves, which means that there's not the awareness about which species are even present in an area, which species are most at risk from the issue, and which species need to be protected because of regional, national, or international agreements on the protection of species. Next, when we consider cost, there are a certain amount of costs involved, and therefore it can often be a struggle to get the internal buy-in, the approval to spend this money on protecting birds, because of this mentioned mismatch between value that you get back from taking these steps. The interest at upper levels of companies is often not there without policy obliging action. And therefore, in the next 3 slides, what I'd like to do is address the 3 issues of which measures to choose and how to overcome this, where to implement mitigation measures, and also how to overcome this lack of resources. Now, when it comes to the issue of unclarity on which measures are the most effective at preventing the most bird mortalities from happening and the most dangerous points in the grid, luckily, there is a lot of research out there already. There are international guidelines, for example, from the IUCN, the CMS, the Convention of Migratory Species, and indeed RGI will be releasing a kind of summary document on this later this year in 2023. However, there are also in many cases national guidelines which kind of bring the issue down to a more granular, more regional approach, and the EU has a certain amount of guidelines on this as well. Meta-studies have been released, for example this one on the screen now, from NABU and RPS, Rapture Protection Slovakia, which really summarise the issue in a very comprehensive and easy to understand way. Next, and this one's really key, partnering up with NGOs and ecologists can really give this, this awareness, this ornithological knowledge which is otherwise sometimes missing. It can't be expected that engineers or grid operators know this from out of thin air. However, working with NGOs, working with conservationists can really bring an awareness of species presence, which species are there to be protected in the first place, geographical constraints and the different factors to be brought into consideration, the migratory routes which may pass over the grid and why there might be the perfect place to place these, the local conservation status of species, and indeed also NGOs may be able to help with training and data collection methods. Next, collaboration should be sought with other grid operators, whether TSOs or DSOs from elsewhere in the world. This is an issue that all grid operators struggle with, and indeed by asking colleagues from elsewhere, a lot of knowledge and time and money can be saved. Working together in coalitions, for example RGI or the CMS, or indeed starting new projects, for example in the context of the European Commission's LIFE programme, can be very helpful here. Next, and this issue links to the aforementioned monitoring aspect, it's always good and good practice to carry out before-after assessments. If you think that mortality may be an issue in one part of the line, start researching, start monitoring, start surveying this area as early as possible, because this then gives you the data foundation which you can later call upon to see how effective your measures have been. And this will benefit you, but it will also benefit the scientific community in general. And finally, and maybe the biggest recommendation here, is that early planning will always be cheaper and more effective than mitigation. Planning the grid away from dangerous areas, using data on bird presence to avoid sensitive areas, will remove the problem before it even becomes one. And so this is a key recommendation. So now let's consider how to overcome the barrier of uncertainty around where exactly along the grid to take these mitigation measures for the most impact. And here we're really talking about how to build up knowledge and build up awareness about which areas are the most sensitive and therefore require action. And what we're talking about here is systematic monitoring. Now this can mean starting early to identify the dangerous areas by counting carcasses underneath the power lines and storing this data in a standardized way and building up then the data baseline for before and after studies. And I think the most important thing, the root of everything in systematic monitoring are predefined standards, the rules according to which this data must be gathered. And these rules, these standards can be internally defined within the organisation, or they can be nationally defined, or indeed they can be defined according to EU guidelines, for example, which would make then the data more usable for people across the world. Next, a key consideration is what to do with this data, where to store it. And here we're talking about databases. Many grid operators create their own databases for internal use, and this could be as simple as an Excel table or perhaps a software on a smartphone or a tablet which technicians can use in the field to gather data on what they find as they're working. And this is the case in some European countries, and is indeed quite a simple tool to begin gathering data. However, perhaps these databases already exist at national level and can just be adapted slightly for the use of the grid operator. And indeed this is the case in Belgium, where you see in the top right of this slide a very popular national bird observation website was slightly adapted to allow people who were spotting birds in the wild to select a category which would say, I found this bird dead underneath a power line, and it looked like it was killed by the power line. And indeed, if these databases don't exist, then working with authorities, public authorities or NGOs to create new databases can be a very positive step. And I think something to underline here is that open source data and sharing of data between actors is very important for building the scientific awareness and helping others to take similar steps in future. Next, we can look at creating options for the public to provide data, to contribute then to the awareness of the issue. Indeed, it's often the public who is out walking in nature and who would find dead birds underneath power lines, and therefore we can really use the power of citizen science to build the knowledge here. And here we link to the example of RGI's Bird Portal, which is a German project where we work with 7 grid operators and NABU, the bird NGO, to allow the public to register every time they find a dead bird around a power line, and this data is then collected, reviewed by an ornithologist and discussed directly with the grid operators to build an awareness about where they should implement these mitigation measures. And finally, a very useful tool which can be created is something called a risk atlas, or indeed a sensitivity map. And this is a truly multi-use tool by which data on bird presence, bird behavior, migration routes is gathered and collated and overlain with a map of the grid to identify then which are the most high-risk areas. And this can inform then which mitigation measures should be used on existing lines, but it can also inform planning of new grid routes to avoid important sensitive bird areas altogether. And this is the example on the screen here from Belgium, whereby a sensitivity map was built, working together between the grid operator and the NGO, and really fed into the understanding of the grid operator and has informed their practice since then. And a colleague will present this later. This is also a very positive step generally for building the scientific understanding of bird presence in an area. Now finally, let's turn to how to overcome the barrier of cost, of lack of resources to implement mitigation measures to protect birds. Now here really it often comes down to a difficulty of representing the benefits of taking these measures and representing the relevance of bird protection for the core business of the grid operator. Now of course there are costs attached to taking action here. Bird markers cost, insulation costs, and undergrounding cables can be very expensive. However, we've heard from colleagues in Europe who are very proactive on the topic that they, in their cost-benefit analysis, have weighed up some of the costs of action with the hidden costs that are sometimes more difficult to represent. Now, what does that mean? This hidden cost could be, for example, the potential for a bird to become electrocuted to cause a short circuit and therefore a disturbance in the grid, which might damage the transmission of electricity, which can be, of course, very expensive. Furthermore, it shouldn't be forgotten that taking proactive action to protect nature and birds is extremely good for the public image, and this has benefits when it comes to public support for the necessary infrastructure and building the grid. Next, and as already hinted on a previous slide, more collaboration with NGOs and other grid operators can really help here, can really give tips to get ahead and save time and money. And not just in terms of data and information, but also working with then the teams, the public teams of volunteers, which NGOs often have for data collection itself. And this is again an example that is done in Belgium, whereby volunteers from the public walk along the power lines to actually actively search for bird carcasses. And this is a lot cheaper than training people to do this within the company and having to pay colleagues to do the surveying themselves. Next, a key source of resources can be the LIFE programme of the European Commission. This is an excellent programme which helps many people across Europe to take action on bird protection, and indeed it can be used for mitigation, as in the case of the Safe Lines for Birds project, which will be presented in a future presentation. Also, it's worth mentioning that there is constant innovation in bird diverters and insulation technologies. For example, it's becoming more and more possible to apply bird markers using drones and to use these drones for maintenance. Therefore, you don't need to switch off the power to take these mitigation measures. Also, different types of silicone insulation are being developed, which are much cheaper and more effective and last longer. And as mentioned on an earlier slide, experience shows that early action, really planning well, can save time and money when it comes to bird protection. Thank you very much, and I'll always be happy to answer any questions that you may have.